All right, good morning. This is a video about using applications of the law of sines. I have provided you with a worksheet. So there's 3 problems on this. There's number 59, which we're going to do first. 62 and 66, I'll read the problem as well. 59 says this. A fire F is spotted from 2 fire lookout stations, A and B. Here's the lookout stations. They're 10.3 miles apart, sorry. 10.3 miles apart. All right. And it says if station B reports the fire at angle ABF, it says that this angle right here is 52.6 degrees, okay? And station A reports the fire at an angle of BAF. So this one right here is 25.3 degrees. How far is the fire from station A? How far is the fire from station A? In other words, what is B? That's what we got to figure out. And then it says, how far is the fire from station B? How far is the fire from station B? Which is, what is little a? Because little a is across from angle A. Okay, so here is what we can do. The easiest thing to do is say, what did they give us? Are we law of sines, law of cosines? What can we use here? Well, they gave us 2 angles. Anytime they give you 2 angles, law of sines. Done. So let's figure out what the third angle is by subtracting these from 180. So with your calculator, you're going to say 180 minus 25.3 minus 52.6, and that gives you 102.1. That means that this angle right here is 102.1 degrees. I'm interested in knowing these 2 values. I'm going to use the law of sines, which says the distance across from an angle, 10.3 miles, is to the sine of 102.1 degrees. As A, I'm interested in knowing that, as A, little a, is to the sine of 25.3 degrees. And this is also equal to B, I'm interested in knowing B, is to the sine of 52.6 degrees. And now we can just cross multiply and solve. Make sure your calculator's in degree mode. So first let's just look at these 2 for instance. I will cross multiply here. I'll say 10.3 times the sine of 52.6, 10.3 times the sine of 52.6, and I'm going to divide that by the sine of 102.1, and that gives me that B is equal to 8.36. So if I'm rounding to the nearest tenth, that's going to be 8.4 miles. Okay. I'm gonna use this information. I'm going to cross multiply this equation and solve for A. I'm going to say 10.3 times the sine of 25.3 divided by the sine of 102.1 gives me that little a is equal to 4.5 miles. If I needed to write a sentence, I could say this. I could say the fire is 8.4 miles from, let's see, B is 8.4. So the fire is 8.4 miles from station A. And 4.5 miles from station, the fire in B, station B. You could write a sentence just like that. Okay, that was number 59. Okay, number 59. Okay, let's look at number 62. 62 reads, a suspension bridge is to cross a river. Okay, so here is a river. Here's a river, okay? A suspension bridge is to cross a river from point B to point C. So they give you a little picture. So over here on the bank, there's point B, okay? Here's point B, and here's point C. So they're going to build a suspension bridge right there. And then it has some other information. It has another point they've located called point A, which is over here on this side of the river. So this is C, this is A, this is B. And so we know distances here, but this is where the bridge is going to be built, right? Okay. So it says, a suspension bridge is to cross a river from point B to C. Oh gosh, let me make this C, sorry. From B to C. Distance AB is measured, AB right here is measured to be 0.652 miles. So let me get a marker that can write a little better. 0.6, this is 0.652 miles. Okay, so this would be little c in our convention. Okay, and then it says that angle ABC, this angle ABC is 81.3 degrees. This is 81.3 degrees. So that's angle B. And then BCA is 41.4 degrees. 41.4 degrees. So, what did they tell us? They told us two angles and a side. Since they gave us two angles, law of sines. That makes it real easy. Let's subtract from 180 and figure out what angle A is. What is angle A? Angle A, and I'm having to do that because I drew my picture so tiny. I'm going to take 180 and I'm going to subtract 81.3 and I'm going to subtract 41.4 and I get 57.3 degrees. Okay, now what do I know? I know little c. What did they even ask? They said, compute the distance BC. Compute the distance BC. BC in my convention is little a. What is little a? So let's see, we need to figure out little a. So we'll say little a is to the sine of the angle A, which is 57.3 degrees, as what information do we know? We know this side, 0.652 miles, is to the sine of 41.4 degrees. Let's cross multiply and figure this out. We'll say the sine of 57.3 times 0.652 divided by the sine of 41.4 gives me 0.8296. 0.82966. Now, I'm going to round it to 3 places because that's how much everybody else is being rounded. So let's see, 0.829, if I round to the 3rd place, this 6 will round up. That will make that a 10. That will make this a 3. So this is 0.830 miles. If we write a sentence, the distance from point B to point C is 0.830 miles. Okay, here's the last one, number 66. It's about the tree. Okay, so let's attack this one. And then we'll be done with this video. Alrighty. Here we go. They say a tree growing on a hillside casts a 157-foot shadow straight down the hill. And they give us a picture, which is nice. Find the vertical height of the tree if relative to the horizontal, the tree slopes 11 degrees and the angle of elevation of the sun is 42 degrees. So, here we go. I'm going to draw a picture. So what we have here is a horizontal. Okay. And so then what we also have is a hill. So we have a slight grade, which is slight, it's at like 11%. This might be more, but, and what we have growing on the hill is a tree. So here's our tree. And it's got some height here, right? Okay, so what are we asked to find? We are asked to find the height of the tree. This is what we're after. The height of the tree right here. How tall is it? What is this distance, okay? All right, but what's interesting is, so it's growing like this, but if it were to, here's the height of the tree. If we were to cut it here, we could make a, so the next thing is we have this angle of elevation right here going up to the sun, right? So here's our sun, here's our tree, here's our shadow that's being cast right here. This is the shadow that's being cast right there. So we have all this little stuff going on. All right, they tell us in the picture, it says, a tree growing on a hillside casts a shadow of 157 feet. So that means this part right here, the shadow is 157 feet. All right, then it says, find the vertical height of the tree, this distance x right here, if relative to the horizontal, the hill slopes at 11%. So this little angle right here, where the green, which is supposed to indicate the slope of the hill, this little sliver right here is 11 degrees, okay? And then it says that the angle of elevation, what am I looking at? The angle of elevation of the sun is 42 degrees. So that means here's the sun from here to here. If we looked up, this angle of elevation is 42 degrees. Okay, so what we have here are two triangles. Do you see this one with the 90 degree? Let me emphasize this in red. If this were not drawn at an angle on the slope, but it was drawn just straight down the horizontal, we could make a 90 degree angle right there, okay? And so this is the angle of elevation with the sun. So from the horizontal up to the sun is 42 degrees. And this is 90. So we could figure out this angle right here by subtracting from 180. So let's do that. Let's see. We've got 180 minus 90 minus 42. And this gives me 48 degrees. So we can figure out this angle. Okay, that is helpful because what we really need to know is this height from here to here. So now I'm going to pull out the second triangle that we see that's on the slope. So here we go. Here is the slope. Here's the second triangle that we have. Here's the slope. Here's the tree. Here is this angle. Okay. This is the tree right here. So here's the tree, right? Here's the sun up here. Okay. And this is not horizontal, but this is at the slope. So right here, this is the shadow right here. So the shadow that the tree casts right here, the shadow, his length is 157 feet, right? All right, and this is the trunk of the tree right here growing up. And here's the trunk. Okay. All right, so what do we know? Well, this angle right here, 48, in this triangle that makes with the tree, and this is the same angle. That's the same angle. So this is still 48 degrees. So that's helpful. Could we figure out this angle? This is the angle between here and here. And we can, because the whole angle is 42 degrees, but this much of it is taken up by 11. So if we subtract those, we'll get 31 degrees. So that's what this one is, 31 degrees. Once we know that, we can figure out what we need to know. If this is what I'm interested in, x, let's set up law of sines. I have two angles. If we wanted to know this angle, we could figure that out. I don't even think we need to know that to figure out what x is, but let's just, for curiosity's sake, let's just do it. Sometimes you default and say, oh, it's 90, but it's not. We'll take 180 minus 48 minus 31 gives us 101. That's what this is, 101 degrees. Okay. We know all the angles. We need to know this side. So we'll say x is to the sine of 31 degrees, as 157, the length of the shadow, is to the sine of the angle opposite, 48 degrees. And we'll solve for x. 157 times the sine of 31 divided by the sine of 48 gives me that x is 108.8, or about 109 feet. We could say the length of the shadow, oh, not of the tree, not of the shadow, of the tree, the height, I should say, sorry. The height of the tree is about 109 feet. All right, cool.